We are solving and writing multi-step equations. Now, it's notes, hands down. When we go through this, a lot of this table is already filled in for us because truly this is going to be more of a reference sheet than anything. As we come across word problems, there is going to be key vocabulary or key words that tell us what operation that we have. So, for example, if we looked at our first row, we can see that for addition, we have sum, total, more than, increase by. On the right, where it says translation, I want us to be able to actually write the mathematical version of this. And so if I see the sum of x and 12, okay, again, sum is addition, and so this is really x plus 12. Now, subtraction. Things we're going to see: difference, fewer, less than, decrease by, subtracted from, fewer than. Subtraction is the very tricky one. Subtraction is the one in which you need to carefully read what we're looking at, because the phrase or the way it's worded determines what order it needs to happen in. And so for this first one, the difference of 12 and 5, this is simply 12 minus 5. For the second one, however, 8 less than y, when we see the word than, it needs to set off alarms in our head that these two need to switch places. And so this is not 8 minus y. This is y minus 8. And so again, when we see less than, you're going to see me make a lot of these arrows. They have to change positions. Now, subtraction admittedly is the only one that's this sort of difficult and requires a sort of critical thinking or critical reading. Everything else is fairly straightforward. Multiplication, product, times. I'm going to include of on this. Of. Oftentimes when we deal with fractions, we'll say something like, what is 1/2 of 12? It really means that we're taking 1/2 and multiplying it by 12, right? Percent is another big thing where this happens. 35% of 20. That's really multiplication. Now, the product of 4 and a number. When we see a number, do we know what that number is based on this problem? No. And so this tells us that we have to use a variable. Now, if you want to use x, y, whatever it is. We're going to use n quite a few times because obviously number, n. However, this would be for x. And then 4 times a number, again, I don't know what it is, and so this is actually the same thing, 4x. Two different ways to get to 4x. All right, and then last one is division. So quotient divided by, sometimes you might see out of, some multiplication you have of, division you might see out of, and so we can add that. Like 3 out of 5, right? That's how we create fractions. And so the quotient of 15 and 5, again, division, you can just go left to right here. This is either 15 over 5 or 15 divided by 5. Either way you prefer to write it, both will get you to a correct answer. Make sure I have eyes, make sure we are writing. Any questions on the front page? All right, once you've got the last set, flip your notes so that I can see, please. All right, so example 1, complete the table below to translate from English to algebra. So you are writing the same style of translation that I just wrote. And so 5 more than x, raise your hand. What would that be? How would I write that with math? 5 more than x. Raise your hand. 5 plus x. Or even x plus 5. Again, addition can go either way. I want you to go through, complete the rest of this table. You can work with a partner. You're going to get 2 minutes. Go. I'm also going to zoom back out to the front for anyone who needs it.
Yeah, I need one. I don't know what that is, bro. I think it's like cube is 3. So that's like yeah, a number cube. So it doesn't matter what number.
Careful. Read multiplication.
4. Wait, what's twice a cube? Twice a number.
Hang on.
And then a number cube. I can't see this.
Yeah, you're doing the algebra version. Question. All right, I need all eyes. What's up? 3, and in 2, and all eyes. What's up? In 1, please. Thank you for that. Love you over there. All right, thank you. Camera over there. All right, Alicia, thank you. Very head up, please. All right, so raise your hand. 7 less than y. Raise your hand. Y minus 7. Please make sure less than. We gotta swap them. Twice a number. Raise your hand. Sage. 2x. Now, a lot of questions came up about this one. Twice is a way of saying 2 times. Obviously, like, because English is such a muddy language, we don't do that with any other number. Like, we don't say thrice, for example. Just a way of saying 2 times. A number cubed. X. Careful. Yes, I know what you're talking about. I want you to say it in a better manner. Yes, x to the power of 3, or x to the 3rd power, or obviously moving forward, x cubed. All right, let's bring it back, please. The quotient of 2 and x. Raise your hand. Quotient of 2 and x. That's here. 2 divided by x, either as a fraction or 2 divided by x. Either one. A number squared. Raise your hand. A number squared. Raise your hand. Raise your hand. X squared. What power is square? 2. Thank you. 12 subtracted from z. Be really careful. 12 subtracted from z. Alex. Z minus 12. Again, subtraction is the one where you got to be really careful and read this critically. The order needs to change on this one as well. A number minus 2. Raise your hand. A number minus 2. This here. Ooh, careful. Is this 2 minus x? No. What should this be instead, Michael? X minus 2. All right. I'm going to run through the last three because we've seen ones like this already. This is 4 minus y. Again, the word than tells us that it's got to switch. The sum, addition, p and q, p plus q. Product of two numbers, x, y. You can have other letters. The key for the product of two numbers is that they need to be different variables. They need to be different variables. Any questions on the table? All right. Shift to example 2, please. I want you to silently read example 2 and annotate. Silently read example 2 yourself and annotate it, please. All right, you've all had a chance to raise your hand. Who can read example 2 out loud? Nice and loud, please. Amaya, nice and loud, please.
The sum of two consecutive even numbers is equal to the number of the
Thank you very much. So, there are a few things, there we go, we got to be really careful of here. First, we can talk about this. The word is. The word is in math is literally where you put your equal sign. The word is literally where you put your equal sign. Now, with that, consecutive. We need to know what consecutive means. Does anybody think they know what consecutive means? Ooh, I saw a few hands. Michael.
Like repeated, not repeated, but right after.
Ah, there it is. And so for consecutive numbers, these are numbers that are one after another. One after another. So if we're thinking about, if we are thinking about consecutive even numbers, an example, 2, 4. Those are two consecutive even numbers. Another example, 6 and 8.
Barfield.
So again, 2 and 4, 6 and 8. It could be 22 and 24, 20 and 22. Every time we go from one even number to the next consecutive, what am I doing to it? From 2 to 4, from 6 to 8, 12 to 14. Raise your name. Say it again. Multiplying by what? 2. What is 4 times 2? 8. Is that 6?
You're adding
Okay, so I'm adding by 2. So 2 and 4 is the one where like we sometimes, totally fine. 2 and 4 is there to like really focus sort of the difference between those two. And so every time I go to a consecutive even number, I add 2 to whatever one I was last on. 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 2, 10, and so on. The reason I'm saying this is because if I need to know what these numbers are, my first number, I'm just going to call n. But the second number, well, to go from the first to the second, what did I say I have to do to it? Add what? 2. So this is n plus 2. This type of question is a standardized test favorite. I am telling you right now, like, I know for a fact you will see at least one of these on an SAT. I know for a fact you will see at least one of them on our Regents. I know for a fact you will see at least one of them on your IA. This type of a question is standardized tests' favorite thing to ask for math. Why? I don't know. I don't know what started this weird trend where like consecutive even or consecutive odd numbers are like this whole big thing. However, it is. So from here, I can now set this up, right? Originally, I had, okay, first number plus second number is equal to what? What's it say that they're equal to? Quinn. Yeah, 138, right? This is right from the problem. And so now that I know what this is, I can essentially take all of this and say, oh, well then this is actually n, there's my first number, plus n plus 2. There's my second number. And that's equal to 138. Again, to be clear, first, second. From here, this is just like a 2.5-step equation. We know how to solve these. N plus n is what? What's 1n plus 1n? 2n. 2n plus 2 is equal to 138. Okay? Raise your hand. What am I going to do to start on both sides? Michael. Take away 2. If I say raise hand, raise your hand. Do not yell. 2n is equal to 136. Raise your hand. What am I going to do on both sides now? Tay. Divide by 2. And I learned that n is equal to, you can use a calculator for this. Once you have it from your calculator, raise your hand. Raise your hand. Say it again. Sage. 68. All right. I know that n is 68. Awesome. Have I answered the question? No. What else do I need to find, Tay? Both numbers. And so I know that n is equal to 68. Again, this is coming from this up here, right? It says, find both numbers. N is 68, which means that n plus 2, don't overthink it, is what? If n is 68, n plus 2 is 70. Thank you. All right, bring it back, please. All right. There. All right, let's bring it back. I'm super not sure why we're talking all of a sudden. Put the hands down. Are there questions on the notes? All right, then. I'll zoom out a little bit in case you need to grab anything. However, fold your notes. Get them glued in. You got 1 minute. Go.